Welcome to the Big Idea podcast, where we focus on food. Today we're going to be talking to Tim Lennox, who's one of the early team members in SoundEats, a company in the Pacific Northwest focused on using cultivated technology to create seafood. So a really wide-ranging conversation today, about 40 minutes give or take, and I take the advantage of the fact that Tim is such a knowledgeable person to ask him questions beyond SoundEats and his company, and actually a little bit more into cultivated technology and how we're going to develop the industry. So I hope you enjoy the conversation today. Reach out to me or Tim and let us know. Thanks very much. All right. Tim Lennox, SoundEats, welcome to the Big Idea podcast, where we focus on food. Really good to meet you. Not meet you, I've met you, before, but really good to talk to you. How are you doing?
Doing great today. Thank you. Glad to be on.
Fantastic. So we're going to do what we normally do. I'd love to find out about your company, about you. Tell us what you're up to.
Sure. Well, SoundEats is a cultivated seafood company focusing on lean white fish, and we are intending to be a direct replacement for the existing production process of white fish in the global marketplace today.
Okay, brief and to the point. We're done. That's the podcast over with. Thanks for coming along. I really appreciate it.
Absolutely.
So how did the company get started? Let's start at the beginning.
Sure. Good backstory there. So I came on to the team. I had previously worked in investment banking, running a bespoke seafood practice out of Seattle, and really got to the point where I was looking around going, man, I don't know if there's a good long-term viability here. The global seafood industry is going to be around for many years to come, but got to a point with a young daughter and looking to make sure that she had sustainable seafood and for generations to come going forward, and wanted to look at something a little bit more long-term on that front. With that, started looking at a couple different alternatives and really came across the team here in Seattle that had gotten started, a group of about 6 professors and industry professionals, predominantly in the therapeutic research space, developing muscle tissue from induced pluripotent stem cells, a recently new technology that they have really been focusing on muscle dystrophy and the like, and had gotten to a point where they saw a lot of these cultivated companies putting out claims that they felt were not substantiated in sound science, and with that wanted to take their technology and experience in growing muscle cells from not just helping the folks that are burdened with the horrible disease, but also then to really make a broader impact in the overall global ecosystem and be able to provide a solid source of food for generations to come. And so with that, met up with the team, really got behind their scientific approach and taking a very first principles approach on developing cultivated seafood, and made the plunge in, and it's been a heck of a ride so far.
So did you have, prior to investment banking, a science background, or this was just sort of more mission-driven than it was experience-driven?
No, certainly didn't have a deep science background going into this. I spent about the first 6 months of my time with the company really understanding what it takes to grow cells into muscle, and thankfully there's a couple professors on the founding team that were very good teachers for me, and with that really got up to speed on what the other companies in the industry are doing, what we are doing, how we're different, and really wanted to establish a good solid base of understanding, and I think that I've got a pretty good handle on it now thanks to some great teachers.
So those great teachers were the sort of founding folks of SoundEats. Who else is on the team now?
Sure. So we have 2 professors at the University of Washington, David Mack and Alec Smith, who are at the Institute of Stem Cell and Regenerative Medicine in Seattle. We've got a gentleman by the name of Nick Geisey, who is the CEO of a stem cell therapeutic device, and Janot Muster, who is also based here in Seattle, who has a deep background in fish biology and build out of lab facilities. We then also have a co-founder in Italy at the University of Torino, Alessandro Botero, who's really leading our genetic engineering platform, and Greg Potter, who's out of Nova Scotia and is leading our bioprocessing scale up. And I think it's really been a unique opportunity to really bring individuals with their specific areas of expertise, as this is such a massive challenge to be able to grow industrial scale production of cells and muscle tissue. And so with that, the team that we've assembled is really one that has their various levels of expertise in each component there. And that really allows us to draw in those individual talents and expertise in each particular area within the developmental process, and has really allowed for us to have a cohesive scientific roadmap on how we are going to be able to do this at a truly industrial scale.
So what are we talking about here from a timing perspective? It sounds like, you know, you and your team are actually building everything with a view to scale, which I love, by the way, because I've spent a lot of time talking to people in this space, and they're very enthusiastic often about the science and have no clear view to how to take that science and make it impactful and beneficial to, you know, humanity. So it sounds like you and your team are actually not, you know, building the team and starting at the beginning with a view to scale and commercialization. Is that what I'm hearing?
Absolutely. I think from a very fundamental standpoint, we are utilizing stem cells, which we are going to be deriving from tissue cultures through a process that is well established in the human and mammalian system to have induced pluripotent stem cells. So we're able to take a cell from a tissue culture. Ultimately, we will be taking a fin cell culture so that we won't actually be euthanizing the fish that we're going to be using. But in our early stages, we will be needing to take an actual tissue culture, turn that cell into a induced pluripotent stem cell, apply some genetic engineering to remove some of the very expensive production costs of the growth media as a growth factor, which enables these cells to grow in culture as opposed to in a organism or a living fish. And with that application, being able to scale and proliferate those stem cells at a massive scale and then differentiate them into actual contractile muscle tissue, which is really what you're eating when you eat seafood. So you're actually eating the muscle tissue of the fish, and that's ultimately what we are growing in our bioreactors, is the actual contractile muscle tissue, which will then enable a very much a one-for-one like-kind replacement to the existing inputs in the industry.
And how do you think about that scale question? How does SoundEats move from that biopsy at the very beginning to significant volume?
Absolutely. I think there is a little bit of understanding on that entire process and what it takes. So when we take those cells, we then put them into a culture media, which is a variation of amino acids, proteins, sugars that allow those cells to grow. And one of the, I think, I'll say legacy, which is kind of funny to think about legacy cultivated companies, but the companies that are currently going forward are looking at more of a fibroblast cell, which is more of a connective tissue or skin cell. And we're actually going and making that contractile muscle. And as we think about scaling that process up, being able to have these cells indefinitely proliferate, which is the very nature of a stem cell, is to continue to proliferate and not have to go through a sentence or immortalization process and hoping that that cell is going to continue to proliferate into what is ultimately the muscle cells. And so as we think about scaling that up, is really being able to take these cells that are by their very nature continuing to double and proliferate, scale that up, and then through a media formulation change, enable those cells to turn into, from stem cells into muscle cells. And that's really where we are looking to take that product, which ultimately we envision a longer term process to get to that kind of structured center of the plate fillet. That's certainly in our scientific roadmap, but that I think is much further down the road on what we are looking to do here out of the gate. But that's really where we are anticipating being in a position to massively scale our production process. And through the power of genetic engineering, the technology that we have is our proprietary CRISPR enabled edits that we're going to be doing, we're able to reduce the cost of those growth factors and the inputs into that media to really drive down the scale. And I think that's really a fundamental difference around what we're looking to do, is to rapidly accelerate down that cost curve and then incrementally look to build back additional elements to get to that center of the plate fillet.
So one of the questions, well, there's two things that are bubbling around in my head based on our conversation so far. One is you've used the word genetically engineered a few times, and you're going to have people listening to this podcast sort of focusing in on those genetically engineered words and wondering, what does that mean in terms of the output? But, and I'm saying that as a heads up because I think we're going to get there. So you've got a chance in the back of your head to sort of think about how you want to respond to that. But what I'm really interested in is, what can we do, i.e. not just Big Idea Ventures, but let's say the corporate environment, let's say governments, let's say all of the people who are sort of interested in food security, protein production, and so on. What can we do as a group, as a series of folks with different resources, different funding, and so on? What can we do to help companies like you to scale your technology so that it actually has a sustainable and beneficial impact? Because there seems to be this gap between a lot of companies out there focusing on cultivated and impact, the ability to actually do this at scale and not have to fish the ocean so aggressively, not have to keep animals in a large factory farm type of environment, etc., to provide us with the protein we need. What can we do to support you and you and companies like you in the cultivated category? Is it just funding? Is it more than that? Is it access to facilities? What's the nirvana here?
Well, I think there's a couple different elements. One is that there have been, as this industry has continued to grow, there are specialized players that have been able to enable that acceleration. In particular, we are looking to work with a couple cultivated CDMO focused, so CDMO, a contract development and manufacturing organization that will is focused on this space that allows us to accelerate that scale up process. So being able to move from milliliters to liters to tens of thousands of liters. And as we look through our scientific roadmap on how we're going to get there, those enabling companies are really beneficial to us to say we don't need to go out and buy these incremental steps of bioreactors. We can outsource that to a third party to enable that scale up, which reduces the dollars that we need to go forward. We're also working with a media optimization company that is going to be transitioning us from pharma grade inputs to food grade inputs through some of their machine learning and technology that they have on identifying the certain compounds which are needed and necessary to maintain our cell growth on a go forward basis. So I think there's a lot of folks that are really able to come to the table here that have various levels of expertise on that front. But I think the critical question, and I think that's one that's really a big outstanding question to the broader cultivated protein space, is really being able to have that production scale. If you think about where we are trying to compete against companies that have had decades, hundreds of years of facilities improvements, incremental investment into their facilities, and we're trying to start from scratch. And I think that's a very challenging element to get to, but one that is something that will be overcome with time. And I think there is a component of that it is dollar investment, but I think coming up with the right structure around maintaining the return profiles from the technology companies like ourselves and the actual production companies that would be looking to actually facilitate the large scale CapEx needs for these large manufacturing facilities that are really greenfield compared to somebody who already owned a factory that had outdated equipment that are really just merely updating things as they look through their traditional production processes. And that certainly is a challenge that we need to overcome. But I think as we look at where we can start identifying potential off-ramps for ancillary products is another component that is certainly a challenge for the cultivated industry. If you think about a fish fillet, for example, that fish fillet is about 25 to 40%, maybe upwards of 50% of the gross weight of that particular fish. But the remaining 50% is also being used in other byproducts that are able to substantiate and generate revenue for those companies. And so really the true cost of that fish fillet is much higher on a one-for-one basis than it would be on what the actual fish that was caught to be able to do that. So that's another challenge that we need to overcome, to start looking at, are there other byproducts that we can do? What could our spent media be used for, and the like? So I think there's some new things that we need to think about down the road on how we could address some of those situations. But I think really being able to figure out, first and foremost, having the science at a point that is actually scalable. And I think that's really where we're focused on, is really developing the scientific roadmap and the milestones needed to ensure that these cells can scale at massive levels that allow for the high degree of output that is needed.
I see, when I speak to companies in this space, I see there are lots of different kinds of companies. And I don't mean in terms of what specifically they're doing from a cell perspective, i.e. beef versus, fish versus whatever, but in terms of how they approach the problem. There are companies who approach the problem by having a scientific question that they need to get answered. They answer the question, and then they discover another question that needs to get answered. And it's a bit of a circular process. I wonder, and this is just from my background, and I'm not a scientist, but I wonder if doing is actually part of the equation. So in other words, yes, have the scientific rigor, yes, have the scientific testing and understanding, but at some point you need to actually try and build it. You need to try and make it happen at a larger scale, and you need to walk out of the lab and start deploying what you've learned in the lab in the real world. And I'm not suggesting the lab isn't the real world, but you know what I mean.
Absolutely. I think that's an element that we've really kind of thought about in the construction, in the founding group of our team, and really having the bioprocessing expertise in conjunction with the core cell line development in the genetic engineering to say, okay, we're going to be doing these, but we're also getting input from our bioprocessing to say, okay, how are we going to be able to take that work in the lab and be able to scale it? And I think that's really the team approach that we're attacking this problem with, frankly, is having these various levels of inputs at each developmental stage to ensure that we are really trying to get to that ultimate goal of being able to produce millions of metric tons of this product.
I think there may be another element as well beyond how to scale the science, which is how to create a food product. So in other words, having somebody on team, either as an advisor or as a team member, who has actually been through the process of developing food products at scale and getting it through the multiple distribution systems. Because sure, the science is an incredibly important and difficult step. Scaling is something that many people haven't even really got to yet. But beyond that, you've got to start thinking about how to make it a product that people are used to consuming. So having it, identical to products that we have been eating and used to eating for many hundreds of years, getting it into the different distribution channels, grocery, food service, etc. there needs to be people who are part of the equation who truly understand food production, and the margins of food, if that makes sense.
Absolutely. I think that's maybe leads into one of our first products is going to be a surimi based product. So in the traditional surimi process, you take a fish, it is caught and then headed and gutted, skinned and filleted, extruded and broken down into its myofibrillar protein. And that's really where the output of our bioreactors is going to be that same myofibrillar protein, which is going to then be frozen into a block, and then from that point is sent to a secondary processor, which then takes that surimi block and mixes it with other flavoring components and the like to make what you think of today in surimi. And surimi is the main input in a California roll, for example. And a California roll comprises about 25% of all sushi consumed in the U.S. So it's a very popular product. Most people don't even know exactly what that is, but it is predominantly a Alaskan pollock whitefish, and that's really what we're focusing on, is a lean whitefish that will be a one-for-one replacement into that existing secondary processing component. And we've already had conversations with several companies on that front on being able to take our surimi block product and insert it into their existing production lines. Some of these companies have the ability to take their traditional surimi production and convert it over to a fully kosher production line, and then back to their traditional. So the ability for those secondary processors to take our product, convert it to a cultivated production run, and then back to their traditional is something that we've kind of thought about on how we are going to be getting into that secondary market that you're talking about, actually into the consumer's hands, distribution and the like.
And you guys are focusing in on North America in the first instance?
Out of the gate, yes, that is our plan. I think our secondary market will certainly be the Asian market, whether that's Japan or South Korea, as we look to really tackle the higher end surimi market, which is a kamabuku product or the like. So I think there's a lot of different avenues we can go down through that route. I think certainly with our genetic engineering, which I know we'll be talking about here probably in a minute, but that's going to certainly limit our ability to get into the EU for the foreseeable future. And that's frankly okay with us, as we, to get to scale, we're going to have limited product out of the gate and don't need to be a global in every market right out of the gate. It's just not going to be functional. So that's really where we're focused here, is first and foremost in the U.S. And then moving to Southeast Asia, or to Asia, excuse me.
Got it. Do you see most companies, and I'm opening that door now, genetic engineering. Do you see most companies in your category approaching it from a genetic engineering perspective, or is that a decision you sort of took as the way to accomplish the kind of cost basis so that you actually had a feasible business? There are a lot of companies in the cultivated space who are sort of hoping for the best when it comes to cost effectiveness and scale. It sounds like you're actually trying to build it in terms of the processes you're using.
Yeah, a couple of things to unpack there. First, I would say, yes, we are very much have identified that the greatest cost to developing cultivated protein is the growth factor inputs. That comprises, estimated to be about 96% of the total media cost is derived from three primary growth factors. And we have the technology to be able to remove those from our production process. So that's kind of maybe bucket one. So we've kind of identified that. Companies that are trying to go GMO, well, I'll get to that second. I think maybe let's just tackle the genetic engineering component. I think it's something that has gotten a bad name in a lot of respects, rightly so, but from a understanding of where we are as genetic engineering with our food, we've been doing that since the beginning. That's how we are able to produce food today, is through we'll call selective breeding, which is a form of genetic engineering. But if we think about, we could spend probably hours talking about this, and I won't, I'll cut myself off, but from a very, basic example would be a banana. If humans ceased to exist today, bananas would go extinct as we know them today. The only way new bananas are able to be produced is by a graft of an existing banana tree, which then enables more production of those bananas. So, as we think about an organic banana, it has been genetically engineered to not be able to reproduce on its own. We've got watermelon, for example, that is seedless. That's genetically engineered watermelon.
Grapes that are seedless.
Exactly. So I think there's just a lack of appreciation for what is genetically engineered and what isn't, and we're really kind of taking the power of selectively doing what we need to be able to enable the production at a lower cost. And so that's really where we've come from on that front. And when we think about as I was kind of mentioning earlier, the other cultivated protein companies that are going for a non-GMO designation is interesting, because all of the inputs are derived from a GMO process. So the growth factors that I was referencing earlier are derived from a GMO process. So those inputs are being derived from GMO and then being said not GMO. And I think that's another interesting dynamic as we think about even beef today. You can have a non-GMO beef, but it could have been fed GMO corn or soy, but it's not detected in that end product that is the beef that you're eating.
What I often hear is the process we've used to create the meat or the seafood or the whatever includes some genetically modified processes or aspects or ingredients or whatever it might be, but the output that comes out of that process is distinct and therefore and is not genetically modified in any way. So they're sort of having their cake and eating it too, in a sense. It's like the output is non-genetically modified, but we needed to modify, I don't know, the yeast or the whatever that was the growth, we needed to modify one aspect of it in the beginning, but the output that comes out of it is not modified in any way. It's identical to a traditional X.
Absolutely. I mean, I think that is a delineation that is out there today, and is one that I think there just needs to be a recognition and a viewpoint on what that ultimately entails. And I think from our standpoint, we have very much embraced the power of technology and where we are in 2023 versus decades ago. So I think that's a element that is something that more and more people are recognizing, that the ability to have our seafood grown in a controlled environment where we know that there are, no contaminants, there's no outside microplastics or other elements that are contaminating that food product, is something that, we really feel is going to actually be a differentiating factor. And the younger generation is something that I think is much more in tune with the power of technology around that, and more open to that consumption of that type of food. I think there's also the other component of, we don't anticipate this being a product for everyone. So we recognize that there's, going to be, now 8 billion people in the world. And when we are at a situation where traditional seafood is either price prohibitive or cost prohibitive, but you still want to get the wonderful power of seafood, the great benefits of the omega-3s and the nutritional benefits of eating seafood, that will outweigh any of the potential negative connotation surrounding a genetically engineered product.
Perfect. If everything goes to plan, what do you think from a percentage perspective will cultivated be from a seafood perspective in, let's say, a decade?
Well, a decade would be, I think, a short period of time to make a material impact into the seafood industry. I think today it's about a $406 billion industry globally. That's right. Highly fragmented across both I think the most traded protein or internationally traded protein in the world. and is one in which I would anticipate being in the low single digits in 10 years if we are able to execute on what we're hoping to do.
Yeah, you guys versus I'm actually sort of was more referring to the whole industry, like the whole cultivated seafood industry. So, you guys and all the other guys out there, you think you all as a combined entity will be a few percentage points of the total?
I do, and I would expect it to be at kind of the 10-year mark. So if we're at 2033, to be in those low single digits, but have a trajectory that is kind of ramping exponentially as we continue to build out new facilities, bioreactors, and being able to really get the scale component. I think that is really the crux of having the necessary infrastructure to be able to get enough product into the market is really going to be the limiting factor more so than the acceptance level in my view.
Right. So based on your understanding based on your understanding of the category, it's kind of interesting that you actually are not approaching it as a sort of dyed-in-the-wool scientist, but actually somebody from a investment banking sort of business perspective. Do you see or envision the production of cultivated being sort of one or two sizable facilities in sort of focal points geographically around the world? Or do you think because the technology involved and the processes involved, it's actually possible to have more regionally regionally focused and smaller production facilities that require less transportation and less, movement of product? And the reason I'm asking that question, I've sort of realized that you're so thoughtful about this category that I can actually ask you all of the questions that I've wanted to ask others, but didn't know I'd necessarily get a good answer. One of the things I'm sort of contemplating is cultivated going to be, 3 or 4 key facilities in North America, for example, middle, east, middle, west, or are we actually going to have a more diversified, fragmented, smaller facilities, city by city, region by region, which because of the technology, we're now able to grow the food more efficiently, more quickly, more sustainably, locally?
I think that is an interesting question, and it's probably more around the evolution of the production process. I think initially it will certainly be smaller facilities in a regional basis, but from a overall cost component, the transportation factor is one in which is not necessarily a limiting factor. I mean, if we think about seafood today, majority of the seafood harvested in the U.S. is put on a boat, shipped to China, and then comes back to the U.S. and then distributed throughout the U.S. And that is something through a function of, is it one big factory in China? We kind of think of China as a processing hub, but it is really made up of hundreds of factories in and around the China coastal cities that are doing that reprocessing and then going to a specific port coming back to the U.S. So from a logistical standpoint, I don't think that is necessarily a limiting factor. From a functionality standpoint, will really be, is there enough of a workforce that is able to produce this in the localized factories, which would ultimately be the best way to do it, certainly. I think that is something that several other industries within even the seafood space are looking at. For example, RAS or recirculated aquaculture systems for salmon farms, for example, are looking to do smaller production facilities near population hubs. And I think that would ultimately be the best course of action. But there is an element of scale and economies of scale from the various other inputs. So, does it make sense to have a media producer that is next to your facility that is producing the media for your production to then transport that? That's probably the biggest component, is getting that liquid or powder form and then reformulating it at the local production facility. But in an ideal world, would certainly have multiple production facilities across all the major population centers would be, certainly the most environmentally friendly, the most the lowest carbon footprint on that front. And I think that's ultimately where we'd like to go. But I think there is in the initial stages here will certainly be more of a larger regional, larger scale facility. But I don't ever envision it being, a massive production facility in the U.S. and one in Japan and one in China that's really doing all of this production. Just the footprint of that is too massive to be able to do in a single location.
Yeah, I was sort of, in my simplistic brain, I was sort of considering 2 or 3 facilities on the West Coast, or sort of serving the western side of the country, 2 or 3 in the center of the country, 2 or 3 on the right side, on the east side, that would be able to service the whole country. That's sort of one approach. The other is thinking through how to actually use. I mean, the great thing about cultivated versus traditional protein is, with traditional protein, you need to have the land mass to actually hold X number of thousands or hundreds of thousands of cows, of chickens, of pigs, etc., for a certain period of time, 9 months, 12 months, 18 months, whatever. With this technology, there's the capacity to grow similar volumes in days, weeks versus, months, years. So it should be a smaller footprint overall when you consider the land that's being used for traditional protein today, both in terms of hosting or holding the animals on the one side, and B, growing feed to feed the animals for the other part of the equation. The amount of land that's being used today for traditional protein is enormous from both of those dimensions. Take into consideration this new technology that you're sort of front and center around. There's the capacity to do a lot more with a lot smaller footprint, both in terms of land, but also carbon. Obviously, you don't need the antibiotics, you don't need the feed. There's a lot of things you don't need to produce larger volumes.
Absolutely. I think it really is probably more driven by the scale of the bioreactors that we would be ultimately producing. And I think that is a function of, are you able to enable a smaller footprint in a major hub? And so you could have a facility in New York, in DC, Atlanta, and Miami. Is that sufficient enough? Or do you do, a single facility in, say, North Carolina that is able to feed the entire East Coast? I think that is an open question, and one I think that we'll be happy to be analyzing those different numbers when we get to that point.
Absolutely. Do you see the traditional protein providers being more and more involved in and more interested in what you're doing? So from your point of view, you're focused on seafood. Are you guys seeing and experiencing interest from the traditional seafood companies in what you're doing? Is there the potential for partnerships between you guys and them in the future, if there isn't already?
I certainly hope so. I think there is an element of maybe fear unknown around what we're doing relative to what they are in the traditional processes. But I think an element there is really the amount of time that it would take for us to be a true meaningful player. As I mentioned, I think it's really a scale question on when we're going to be able to just have enough output to be able to compete with that. And I think it's the seafood industry has gone through some of these iterations before. Seafood is one of the only proteins that we still rely on wild capture. You aren't going out and catching harvesting a wild cow or pig for your food on that front. But I think that's an element where there's been, this wild versus aquaculture dynamic that, I think there was a lot of frustration and, fear around what that would ultimately look like and how that would articulate. And I think that is one where, I'm thinking of the salmon industry in particular, whereby there was an embrace eventually of, hey, we can differentiate our product as a wild product and still allow for the aquaculture salmon to be able to grow. And in fact, by having more people eating salmon, it actually enables us to differentiate and position and market our wild product as a premium product that is wild by its very nature, and being able to bifurcate that. But I think there was a recognition that more people eating salmon, all boats rise together, and that enabled better opportunities for them down the road as well.
Got it. In my past life, I was involved in developing software and various other things. And there was this sort of understanding that even if you added more and more people to writing the code or money to allocate to the team who were developing the code, it wasn't necessarily linear. In other words, it's not that if you put an extra dollar in or an extra $10,000 in or $1 million, you're necessarily going to get a curve in terms of the development, allowing you to speed everything up, allowing you to solve all of the problems more quickly. Obviously, you do, but it's not. There's a law of diminishing returns there. If you guys got a sponsor, a patron, something from the traditional seafood category, and they said, okay, we're going to place our bets on SoundEats. We think these guys are thinking about it in the right way. Is there the answer is yes. I was going to say, is there still a time period, even with all of the resources in the world, that it's going to take you to get where you want to go? Obviously, the answer is yes. But with those kind of unlimited resources, is this something that you guys can expedite in a 3-year versus 5-year, or a 8-year versus 4-year? How do you feel about what you're doing in terms of if you had the resources you really need to get this going?
It's an interesting dynamic that we've spent quite a bit of time looking at, and I think there is a key limiting factor, and that is that it just takes time for the cells to grow. We just are dealing with biology, and there is that natural limiting factor. By being able to have, at a certain point, more people working on the project, we do get the ability to run more experiments in parallel, as opposed to doing it sequentially. However, there is that limiting factor on being in a position where additional resources are always welcomed. We'll never turn that down, certainly. But I think there is an element to being able to making sure that you're accomplishing what you need to do before you start running down a path that you don't have the necessary foundation that you're building upon. And I think that's something that we're very much focused on being able to establish our iPSC line, being able to put in our first genetic edit, then our second, as we look to build upon making sure that we are not trying to shortcut or build a production facility maybe that isn't capable to match our scientific results. And so I think that's something we're very cognizant about, and one in which there is an element to speed up some of those components, but at a certain point in time, there is a dynamic that's going to take some time. I think if we look at like the power of compute, going from a full room in Stanford to be able to do some basic computations to now having a supercomputer in your pocket, there's an evolution there that, money alone wouldn't have just sped us up to have an iPhone in 2000 versus 2010. So I think there's just an element of time that needs to pass as we are able to enable those building blocks to get to a point where we are able to exponentially scale.
As someone from England, I'm sort of offended that you think of the first room-sized computers being in Stanford instead of in England. I'm going to get letters from people from Bletchley Park, where these huge computers, room size, were originally built by Turing and all the rest. Oh, hello, something just pinged. Anyway, I was going to ask you, what should I ask you that you've always wanted to answer, but no one has ever got around to asking you yet? Is there a question out there that I should have served up to you, and so that you could have knocked it clearly over the bleachers?
Let's see. I think that as we are positioning ourselves for success, I think one of the key components is really being able to align with folks that do have the recognition that this is a longer term journey, and one that we recognize ourselves. We are early in this process, and that there is a component to having the right pieces in place before running ahead and making claims that we can't be substantiated. So I think that's really a element of something that we're looking for in folks that are wanting to partner with us, is really being in a position to understand that this is something that we are limited, as we mentioned, by the biology the cells take time to grow. But I think it's an element that is also to speed up. For example, is a salmon takes 3 years to get going to a harvestable rate, 2 years from the embryo stage to a fully grown market weight salmon. And so we do have the ability to go much faster than waiting that length of time. But I really think that being in a position to have some good partners that understand that this is a journey in which we are taking a kind of foundational first principles approach is really where we want to be.
Perfect. So people listening, what can they do to help you? What are you looking for right now? What are you needing? What kind of, partnerships, etc. are you exploring at the moment?
Certainly. Well, we've been able to get off to a great start with the help of Big Idea Ventures here. So very much thank you for that. And we are currently raising our pre-seed round here. So looking for investors to assist us in continuing our journey here. So happy to get in touch via LinkedIn or via email at tlennox@soundeats.com. And look forward to anybody here that's listening that would like to learn more about what our processes are and how we're doing and what this is going to look like going forward.
So T Lennox, Lennox at soundeats.com, yes?
That's correct. Yes, indeed.
And Tim Lennox on LinkedIn or SoundEats on LinkedIn?
Both of those work great.
Is it SoundEats Foods LinkedIn or just SoundEats?
SoundEats, one word for the Puget Sound. I got a nice map here in the background, and
I was looking at that. That's cool.
So yes, trying to really leverage our ability of being one of the first cultivated seafood companies in the Pacific Northwest, and leverage a long history of seafood in the Puget Sound area.
Amazing. So which is the biggest seafood company in your neck of the woods?
That would certainly be Trident Seafoods.
Trident Seafoods. And they're friendly?
I know the team over there from my prior world, and I think that's something that the existing players in that space, we've started conversations with several of them and are looking at establishing deeper relationships as we move forward, and certainly hope to be partnering with some large players here in the near future.
Perfect. Tim, I've really enjoyed the conversation. I got to apologize because I said before we came on the air today that I was going to give you super simple questions that friends who didn't know anything about the category would ask you in a bar or a cafe. But the reality is I realized very quickly that you know what you're talking about. So I wanted to sort of ask you questions I've always wanted to ask other people, but haven't had the ability. So, feel free when we get off the air to, yell at me, scream at me, throw something at the camera. But I've really enjoyed it, and I really appreciate your insights. It's been a great conversation.
Absolutely. Thank you very much, Andrew. It was a great conversation, and look forward to many more. So thank you very much.
Thanks, Tim. I'm going to press stop record. So thanks again for coming along to the Big Idea podcast, where we focus on food. That was Tim Lennox from SoundEats. And if you want to get hold of Tim, it's T Lennox, Lennox at SoundEats, EATS.com. He's also available on LinkedIn, another great way to get a hold of him. So if you're a potential employee, a potential person from the food industry, if you're a potential investor, or any of those and more, by all means reach out to Tim and engage with him and have a chat. Super friendly, super knowledgeable guy. So that's it. That's our podcast for today. Thanks very much for coming along. I'm Andrew Ive, the founder of Big Idea Ventures. We're focused on working with some of the best entrepreneurs, scientists and engineers in the world to solve global challenges. That's our focus. That's what we're all about. So if you need to get hold of me, you can reach me through LinkedIn, Andrew Ive, IVE. Our website is bigideaventures.com. I'm also on social media and all those wonderful things. So do reach out. Love to hear from you. If you think you can do something to make the world a better place by working with us at Big Idea Ventures, I'd love to hear from you. Okay, have a wonderful day, evening, month, year ahead. And, I'm a firm believer that we can all do amazing things if we just put our minds to it, especially if we do them together. So do reach out. I'd love to hear from you. Thanks very much. Bye-bye.